All right, so this is our capstone project for the Masters in Predictive Analytics and Data Science. The program is switching names at Northwestern. So we have Tara, wave hello, and Nick, and Liz, and Taylor.
Hi guys.
Hello.
Hi. Nice to meet you.
Hi.
So have you guys all been in this program together forever? You're now done?
Yeah.
That's cool.
Yep. This is it. This is the finish line.
Congratulations, everybody.
Thank you.
So let me start.
Our Sparkboard work.
All right.
It works when you connect directly to it.
Okay.
All right, so here's our team. I feel honored to get to work with this group of diverse individuals. Everybody has brought like a slightly different skill set to the project, as you'll see. So we've been able to give a deliverable that's really pretty broad and widespread. So just a couple of expectations to set for everyone before we get into this. These are prototypes and recommendations. We kind of took the attitude of just some recommendations from the outside and prototypes of things. So this is not implementation ready, and there are a lot of different business considerations that are not necessarily built in. Once we get to the recommendations and conclusions piece toward the end, we speak to that, of the different pieces of the space for that in our prototypes and in the, when that would go toward implementation. But just so we're all on the same page that we know, right, we haven't done extensive user testing with each organization to meet their business needs. Like, we're just not in that space quite yet. The other expectation to set, I think, is that all of the recommendations are just how we think data science can help leverage LRNG to do something even bigger and even better. And it's not speaking to any failures, but speaking to future opportunities.
Yep.
So we're all going into that mindset.
Yep. Great.
All right. So the problem statement that we started with is the assessment period. Especially, we have several of the summer youth employment programs that all come into this period where they have a lot of students and a short period of time to grade. So 200 responses in 24 hours. I think some of our use cases are actually much larger than that. So that's our basic problem statement that we started with. We addressed a wide variety of other questions. How can we better leverage our data? How can we better understand the data? How can we facilitate feedback to the students, and how can we help the organizations grade more effectively? We looked at how LRNG as a total can make better investment decisions, and how we can how participating organizations can access the information about their students' progress, as well as improving the user experience. So, in order to address this within the scope of our 10-week course, we narrowed down into the One Summer Chicago Be Payday Ready playlist. So there are 7 XPs. In our data set, we had 5,129 unique users, and the badges and the artifacts go up from there. So this was a really great data set to train a model on. We had enough data to have some accuracy in what we were training.
Jelani, I'm going to wait until a couple more of your colleagues show up, and then we'll take a break and catch you up on what we're doing.
Oh, sure. All right. So here's our solution suite. We have created an analytics-ready data set. So the data that we have internally housed in our database is not necessarily ready to be plugged into a model. This is something that every organization experiences across any data science initiatives, is that you have to prepare the data, make sure that it's ready for what the model is expecting. So there was a process for that. We created the code for the predictive modeling feedback system. We created an executive dashboard that looks at expansion opportunities. We created a web-based Shiny application to look at user or of the students and what's happening with them, as well as a comprehensive user interface design recommendation. So with that, we'll get into all of it. We're going to get into all of it.
Okay.
So next up, we are going to talk about the model, and Taylor's going to walk us through that.
Great. Can everyone hear me okay?
Mhm.
Okay.
Louder would be awesome.
So we're going to just walk through the analysis we did when we first got this data. Just get familiar with what your organization is producing in terms of data and what we can turn around and use for our actual model. And as Mary alluded to, taking all those different data sources and getting them into an actual data set can be a feat in preparation to model. So some things we had to consider and do to get that original data into a form to model. So data integrity was a big one and is always a big one when working on something like this, because if you're going to trust a model's results, you want to make sure that what you're feeding in is actually good, right? So we spent a lot of time on that. Just something to note, submission statuses weren't lining up for us one-to-one in terms of approved, denied, or ready to review. So that was something we had corrected before we had to move forward. We ended up using the students' actual text input for the models. So what they're actually typing in to those open text responses. And so text data is notoriously nasty. So there's a lot of steps that we had to take to clean that up. So removing punctuation, taking out any bad characters. If we're talking about payday ready, so if somebody put like hashtag make some money or something like that, it's not going to do well in our model. So we had to bring that out, as well as taking a word like paycheck or paychecks. It's essentially the same meaning to our model, right? So we had to take that from a plural down to a singular form there. So that was just kind of the data prep before we really got into any modeling. On top of that, we did variable creation. So looking at grading scores, what types of words like nouns, adjectives, past participles, different things like that. And then eventually just turning all of those numbers into, all those words into numbers, right? So we had to vectorize this, which is a bit of a complex process that if we need to get into later, we can do that. And also just wanted to take a moment to talk about the ethical consideration there. So we did, for our model, only use the input that a student provided. And that was very intentional for us because we didn't want to look at a student's gender, a student's zip code, or any demographics information about that student. Because while that information might be good for you guys on the back end to see what actually happened, for us grading, we don't want to be looking at that. We'll introduce biases into our model. So we just looked at the user submission. So if we take a look at the next slide, we're actually going to talk about the actual model and the process we did to get through that. So we were just modeling a pass or fail. Is this a submission that's worthy of moving forward in the playlist or in the program? So we had a couple of different success metrics there. One being area under the curve, which is just how well you classify that. And then additionally, the sensitivity. So we can take a quick moment to talk about sensitivity. We thought it would be better to pass someone who deserved to fail in reality than fail someone who deserved to pass. And that's just you're not going to have a model that predicts 100%. So we would rather err on the edge of passing somebody who shouldn't pass than failing somebody who really should pass. Just don't want to take the wind out of their sails as they're moving through the program. We tried a bunch of different types of models. Our baseline, we used logistic regression, which is kind of tried and true, and ended up getting our best results with something called a random forest. So in terms of the actual performance of the model and as well as the runtime. So this is something that could be run for multiple different XPs and multiple playlists pretty quickly. So you could have a model for every single XP. And I think that's about it for the models.
Yeah, yep. And so you're saying that, are you saying that, sorry, can I ask questions now?
Please do.
Are you saying that for the random forest model, that it would take less than an hour to train the model per XP?
Yeah. So, and what that means is that if you had a program that was just starting with a brand new XP that they've never graded before, we would need the grader to manually grade submissions up front to teach our model, right? So let's say there are 1,000 training model or 1,000 entries, and we train on those, and within an hour, our model could start automatically grading. It would need like about an hour of processing time to actually do that.
And is that specific to Payday Ready, or is that language for an XP? It's generic.
Yeah, that's pretty generic for any XP.
Huh.
Yep.
Just gonna keep making noises. Huh, okay.
Can you also, sorry, do you have the sample size? So, never mind, I'll ask it later.
Okay. Are you sure?
Well, my question is about what is the appropriate sample size that would have to be manually graded?
Sure.
To the point where you could have a high level of confidence in the model. And Mary kind of talked to me about this earlier, but I didn't hear.
Yeah.
Yeah, so for classification and then team as well, if you guys want to chime in here, feel free to. With the classification, that's not always easy to do. Like if you were assigning a value, we could tell you with what confidence after 100 manual gradings, that the model would be able to predict on. So I think we would probably want to set a business rule around that. I would think it would be more in the hundreds than dozens. So you would probably need 100 or 150 before we could really start seeing results. I don't think it could be like grading 15 submissions and then us using that.
What would the confidence interval be at 100?
I think it all depends on the standard deviation. So how much, like how many fails and passes there are. So it could really vary a lot.
Okay.
That's my stuff. Yeah, got it. Have a seat.
Well, this is a good time we can introduce our youth ambassadors. So this is my capstone project for my master's program, and this is my team presenting it with me. So you guys can see what it is, ask any questions that you have. Feel free to engage if you like your participation.
And then we also on the C-Sky side have.
Yeah, you guys can feel free to unmute yourselves and ask questions.
Can I just provide a little bit more context for these guys?
Yeah.
So 2 things. When you're taking classes and at the end of the class you have to give a presentation on something? So Mary is finishing up a master's degree at Northwestern in predictive analytics and data science. And she has a team of other students who are also finishing, and they've done a capstone project together, and they chose to do it on LRNG. So part of what they have to do is do multiple presentations related to what they did their work on. And we are the professional group to which they are presenting to get feedback. So as you think about the presentations that you give in class, this is the next version of those. When you get to the master's level of expertise in a particular area, it's called the capstone project, and it's the kind of work that they're doing off of real data and solving real problems that companies and others need. Okay?
Sounds good.
Thanks, Penny. Great.
Wait, hang on. Do you guys know what predictive analytics are? Can you explain to them?
Definition.
So it's the science of manipulating data to say, or training data to say that I can tell you, so you have variable A, B, and C, and then outcome D, right? Like you pass or fail in this example. And then so later on, you can give me the variables A, B, and C, and I can tell you whether it's going to be a pass or a fail based on all the history of the data. Yeah.
And so that data may be what you did to complete an XP. It could be a click that you've done on the computer. Mary can collect all of that data and be able to predict it. So when you guys are creating XPs and playlists, somebody else is going to be on the back end of the platform looking at the data and predicting what folks will do as you are, what somebody who's completing your playlist might actually do. Okay?
Yeah.
So if you thought that algebra was useless, about using variables,
I understand that.
We can get it back out, don't worry. Does anybody have any other questions?
so they are looking at Payday Ready. You did Payday Ready. So all of this is based off of how do you automate, because you had to write stuff.
Yeah.
So, and then somebody on the other side had to actually read it and give you feedback. Can the computer do that? And not have a person have to do that? So that we can do thousands of them and not have to employ thousands of people to give the responses. So that's what we're talking about.
Cool. All right, so we are going to go on to the Shiny app, and Nick is going to take over here.
Oh, I'm gonna say one more thing.
Do it.
Data science is one of the most growing fields in the country for jobs. So being able to do this and the work that they're doing is a kind of skill set that will always get you a job in the US.
Always, always.
Just saying.
Okay. Okay, go ahead.
Can
Done.
can everyone hear me?
Yes. Yep.
All right. So I'm Nick, and so I'll go over the Shiny app portion of this. And so a Shiny app is essentially a fancy way of saying we used a statistical software to go ahead and prototype what an application would look like. The beauty of this Shiny app is that it's automatically able to go ahead and resize itself for any device that's accessing it. So if it's on a mobile device versus a laptop or a desktop, it'll resize itself, and it's really, really fun to play with. It's also reducing overall development costs because some of the models in the future could also be implemented within the app itself. So you have very little time needed for deployment. And also the way I've coded the app, it's also modular. So it's only calling on data when it needs it. So it's an on-demand data pull request. So it's minimizing data usage. So also same with when you have to pull up the data through your mobile device, it'll try to minimize how much data is being used. And I guess we'll go right into the live demo because I think it'll be a lot of fun to kind of see what we've come up with here.
On internet.
Just want you all to know we pay a lot for our internet. It's not because we scrimp on it. It just doesn't work.
All right.
All right, so this is just the landing page. So we'll start with, so there's 4 different sections here: student experience, XP summary, reviewer experience, and model result. We'll dive into each one first, all of them really, so it can give you an overview of what we're doing. So we'll start with the first one here under student experience. And this first table is kind of interesting. What it's doing is it's looking at a variety of basically all your students within the Payday Ready playlist. And it's essentially letting us know that for each student, how many XPs have been approved, how many are ready for review, and how many XPs need re-uploading for that student, and also how many badges the student has earned. The interesting thing here is the student names are all randomly generated, so it would be pure coincidence if they match up with anybody. But really, we use student ID here to kind of anonymize some of the data for demonstration purposes only. So this is kind of an interesting overview, essentially providing you a high-level overview by student, what's happening with that individual. So if there's a lot of XPs that are needing re-uploads for a particular student, this is a great way to prioritize targeting of what needs to be done. If we go to the next one under student experience, it's under student playlist duration summary. This one is really interesting too, because now what we can do is understand how long is it taking not only all of our students to go ahead and interact with this playlist, but how are they doing overall, each individually. So we can look at and say, if, like, for example, the first student here, Anna Marshall, she's taken 24 minutes to go ahead and complete this playlist. So this will also be a great way to understand cycle time of each playlist. So, is our playlist too long, too short, just right? It's something we could design. And also, you can see there's a lot of outliers here. So like the next one, Reagan has spent over 10,000 minutes.
Yeah.
And
10,000 minutes?
Yeah. So my suspicion there is that when a user logs in, they may not have logged out, or the system may have kept them logged in on that playlist. And so, or they broke up the playlist in multiple days. So for instance, if you start something on Monday and you don't finish it until 2 weeks later, we're assuming that it took you a total of, let's say, whatever that time period would be. And the reason for that is we're looking at the start and end times of the submissions. So as an opportunity, we could also look at tracking each individual playlist as to when it was started and logged off and so on, and create a time series model in the future going forward. But for this general purpose, it was just from your first submission to your last submission.
Oh yeah, this is the first. Oh, okay, this is the full playlist. Got it.
Mm-hmm.
Yeah. Does that help answer the question?
Yep.
All right. We'll go into the XP summary. So this section helps us understand a little bit more about the XPs. And so this first tab is helping us understand the overall summaries by submission status. So if you look at this particular submission status, you can see how many XPs are in what status and how many distinct students there are within each submission status. And the bar plots are also helping you understand essentially the same information, but more of a visual perspective. So this would be also a great way. So if this was updating in real time, you'd be able to see as the days or hours go by, how each student is progressing from each submission status. So then we can go on to the next one under XP summary.
Would you be able to flag who was stuck, or you'd be able to flag where there are problems?
If we combine the duration and a couple more timestamps, we would be able to properly assess if they are stuck at a certain spot. That would help us, especially if they're having to resubmit quite a bit. We could develop a model around that as well. And in this one, we can look at each individual XP now and understand how many have been approved, how many students have been approved, how many students have requested a review or submitted something for review, and how many students have submitted something for re-uploads. You can also filter this by media type. So if we wanted to see if there was a particular media type that's of interest, let's say a picture or a text, you could do so as well. So Mary, if you can just filter for media type and then just click on deselect all first and then choose text, please. And while the model reruns, it'll essentially recalculate. So if we have a lot of text submissions in this case, so an image would probably be a little better, but. And you can see that we have the Savings Ready XP has 44 that has been submitted and 1 ready for review and 22 waiting for a re-upload. Then we can go back into XP Summary and go to the word cloud. Word cloud is an interesting one because what it enables us to do is looking at each XP, we can start to understand what are different common terminology or terms that are being used. This is somewhat representative of what Taylor was describing in his own model where we developed with Random Forest, using some of these words to then predict what student might be submitting, whether it's approved or failed. So if we filter for a specific XP, Mary, if you can go to the filter again, please. And if you click on deselect all and maybe pick banking ready, for instance, it will recalculate shortly. Maybe. We'll see.
Mm-hmm. Yeah.
It is probably is.
Oh, it's doing something.
Oh no. Try again.
Uh-oh.
Could be our
No
internet.
worries. Yeah, or we can just do one of them. If not, we can move on. No worries.
All right.
So here it's actually regenerated itself for all the different terms that are being used in Banking Ready. So we can move on to reviewer experience real quick. The reviewer summary is basically going to give us an overview of the different reviewers as to what's happening. So now we can understand by media type what each reviewer will be doing as soon as it generates. Huh. Can we go to the next one? Did the whole thing crash? Oh.
Our internet's been really spotty too.
Yeah.
So.
All right. No worries. There we go. Okay. So here you can see the reviewer name, the media type, the number of XPs that they're working on, and number of students that they're also reviewing. The benefit of this is to understand resource allocation and balancing. So for example, in this case, you're seeing that Shay Phillips has a lot of different students that he is working with. And so this would be a good opportunity to assess whether they can redistribute the workload and help them review faster some of the individual XPs. If you go back to reviewer experience real quick, Mary, and then go to overall reviewer durations, please. Here you can understand the cycle time of how each reviewer is doing. So the minimum amount of time they spent and median, average, and all that. So it gives you an overview of, basically you can use this information to set goals or targets for each of your reviewers to help them achieve more measurable, more meaningful goals for their performance. If we go back to the reviewer experience and the average reviewer durations, what this is doing is by reviewer and by their XP, we can then see a further breakout of what's happening. So now you can understand if there's a certain XP that's also slowing down or speeding up a reviewer's review time.
Huh.
Would you
And fun.
So what is a
You wanna-
negative 59?
Negative 59 is a great question. So one of the data points when we're calculating, some of the dates are sometimes a little, or the timestamps, I should say, are sometimes in the past and versus future when we're doing the calculations. That's kind of where we would have to look at individual timestamps to see if the timestamp definitions that I'm assuming are correct, and we could change those if needed. But that was my understanding to calculate the min and max durations. What I had to do was use the timestamps that we had available.
So more data
And then
continue to research.
Mhm.
And finally, the model results is more of a optional tab, but what it does is it's enabling you to understand the different the confusion matrices for what the model that we have chosen, the random forest model. So here you can see the actual fail rate versus predicted fail rate, and actual fail and predicted. So false positives and false negatives essentially are more visible in this view by XP. So generally you want in your bottom left and your top right corners, you want those to be as close to 0 as possible. And then your top left and bottom right are the ones you want to be as high as possible. So that would suggest basically a perfect fit if there were zeros on the other ones. So, and then you can choose different XPs to see how the model is performing for each different XP. So.
Great, thank you, Nick. Anybody have any questions on the Shiny app?
I like the way it records data and it's easily shown and the results. Like when you go to the reviewers or the person who did it, like I like how you can see the duration of time it took. So like if that shows up in a lot of people, it can. I don't know what it can say, but like it may be something about the playlist or something. Like it just collects good data to be reflected on the app itself. And I like
Thanks.
I have a question about the actual fail, actual pass. Do you have like what the percentages look like of how, like at what percentage was the model correct versus?
Yes. Yeah. We don't have that in the presentation, but I have that I can get to. Yep.
Kind of the AUC score, right, Mary?
Yeah, so we do have an accuracy metric, Mary. It's close to 90% about.
And so, and then what that says is, so 90% accuracy and the 10% that was inaccurate erred toward the side of pass. So what was the percentage of times that the model failed something that was supposed to pass?
Right, so that's also on that previous slide. I think that's only about 6% of the time. I think it's under 10%, I should say. That's in one of our slides, though.
Let me switch back.
So the sensitivity metric is what we want to look at for somebody who was failed that should have passed.
Mm-hmm.
And so for random forest, we see that only 3.8%, that metric.
3.8%, got it.
Hey, this is Kali over at Concentric Sky. So I was just curious, maybe you went over it earlier before I walked in, but what are the sizes of your like training set, validation set for this particular XP that you were modeling?
We ended up using a 2/3 split. So it was the training sets were about just under 4,000 samples, and the validation sets were about 1,500.
Okay. Thanks.
Great, thanks, Callie. All right, so next we have design. Liz is up. Go ahead, Liz.
Mary, did you want to show the old screenshot first, or?
I didn't put that on here. I'm
No,
sorry.
no, it's okay. I think hopefully everyone knows what the current grader dashboard looks like.
We do.
We don't need to remind you. So yeah, at the beginning of the project, Mary sent over some screenshots of what the current grader interface looked like. And so we conducted a market analysis as well as a heuristic evaluation of what your current site and grader experience, specifically targeting the usability of the tool, looks like. And we also, based on a previously recorded usability test, we were able to get access to, with the representative user struggled a lot with navigating for content and was frustrated by how inefficient the artifact access was. So we hope to clean that up for you here. So over the past 9 weeks, we developed Grade Assist, which you're seeing here. This represents your longer term web design solution integrated with your site's current look and feel. We're really excited to demonstrate how the predictive analytics models fit into your user experience. For the software design recommendation, we adjusted the information architecture of how the grader reviews student achievements. The playlist is your guys' highest content that LRNG offers. So we're gonna lead with playlists and then display children, the XPs in here, and then subscribers, the students, beneath that to streamline it a little bit. So the stats at the top of the current grader page were not very helpful or actionable. They also forced users to start with the playlist status, so like approved or review, and that made the graders go through duplicate steps and additional clicking in order to pull up an artifact. So we flipped that flow around here a little bit, enhanced the stats to be more meaningful for the graders. Here you can easily see which XPs need a review, how many are in work, how many are approved, and how many badges have been earned. And it's easy to see right there which students apply to that metric. Instead of sending graders through a view tunnel to the artifacts, so that top metrics section is now going to be reserved for accelerators. Those are additional shortcuts you guys can use from that stats section if you want to grade at a class level instead of down in the more colorful section that's student level. So we hope it is a lot more clear what actions the graders need to take in order to motivate the students who have not addressed their rejected XPs and what's ready for feedback. And so what you're seeing right now, this is all good, just business intelligence. We demonstrated the technical feasibility for you with the R Shiny app that Nick demoed, and now we're really excited to show you what might be possible and how we envision Grade Assist integrating with your current platform. So I'd like for you to imagine that you're a grader. You can see all of your students here, as well as their progress for each playlist. It's clear who is progressing on track and who needs help. Let's go see how Kelly is doing. It looks like she has an XP that's ready to be reviewed. So Mary has clicked on the review button to look at what Kelly submitted, and we're going to provide the appropriate feedback. As the grader, you will review Kelly's submission and determine if she's demonstrated the associated competency. Here we have the requirement displayed first as a reminder to graders. It was not clear in your current interface what was going on. So if we follow that, the artifact is next, what Kelly submitted right here on the same screen. And so then we have a nice area to provide written feedback. And this is easily managed in one screen. If we assume Kelly understood her bank account best practices, We're going to pass her. Mary's first going to add in some kind feedback and then click approve. You'll notice that you're automatically taken back to the main page and Kelly's status is updated for XP number 4 now. Approved. This is how your graders conduct work today, very manually and one by one. So far, we've just demonstrated user interface enhancements. We've reduced the number of clicks from step 1 through to the artifact, and we've created a reusable dialogue design pattern. But let's say you have 60 more students to review by tomorrow. What we're really excited to showcase for you today is the culmination of 8 weeks of exploratory data analysis, data cleaning, natural language processing, and design thinking. Taylor already talked to you about how AutoGrade works, but it's essentially a model that has been trained on the types of submissions that get approved and which ones get rejected. Mary will turn it on in the upper left-hand corner and see how easy grading will become, but don't blink. Instantly. Everything is great. So what just happened? So 12 artifacts here have just been auto-approved, and if you were spending 5 minutes grading each one, we've just saved you 75 minutes. If all 60 artifacts were ready at the same time, and they're not all displayed here just to save space on the design, it would just continue to scroll down. But we would have saved you 5 hours per XP or 30 hours for one average playlist. Here, 2 badges you can see have been awarded, and 1 rejection has been given out automatically. But how do we know for sure these grades are good? We recommend giving the graders full transparency into this process. Perhaps Mandy, one of our students, has been struggling this week, but the model approved her XP. We want to go double check what's going on. And we can open up that artifact in the same way as before to see what AutoGrade said. We would, so as you can see here, Mary's opened that. We would recommend providing an override option for your graders and allow them to give a fresh feedback if the model did mess up. Our model does show between 80 and 90% to a 10 to 20% ratio of true positives to false positives. And that is really outstanding, but there will always, of course, be a few false positives with any model. So back to the dashboard, the class mastery view is contrasted nicely with the student mastery view. Let's go look at Mandy's profile. We've enhanced it with each of her playlists similar to the class view. She has related student success metrics up on the top, and those are just for her now. So graders can also see all the timestamps here and the history of each of her submissions. You'll notice on the Be Banking Ready playlist, it kept a record of all of them, so including her rejected submission and allowing the graders to compare against the redone one. Again, a lot of these metrics you already have, as we demonstrated in the R Shiny apps. This is really exciting. We took this opportunity to present the data in a more user-friendly way. So if we can double check Mandy's submissions from here again too, I think the auto-approved one. Yeah, so just another way to access the artifact. But yeah, you can go back to the page. So this page includes, yeah, every playlist Mandy has ever worked on. We'd recommend just incorporating that with the profile they have today, any other playlists that they have. They can be collapsible and maybe sort that in order of access. Finally,
sorry, question here. Is the feedback auto-generated? That's the first question. And the second question, if you were to override a given auto-generated response, does that go back into the model to retrain?
Oh, very interesting. So the first one, we do just have 2 recommended feedback items to start, but in the spirit of making it more humanistic, maybe we offer a random 7 successful type responses so that they're not getting the exact same one every time, that it's very obvious that it's a model or a machine, giving me feedback. So that's the feedback one. Then the other one, what was the second question again?
The second question was, you can override the auto response, it looks like. So the question is, if you override that auto response, does that go back into the model as a data point to retrain?
Yeah, I'll pass that one over to Taylor just because we're not doing any machine learning at this point, but definite considerations for the future.
Yeah, so I can speak to that just quickly. So yeah, you'd absolutely want to retrain. Now, on what interval and what regularity, you would have to figure that out. And then I can also just add on to Liz's first comment. We didn't do any actual feedback recommendation besides just, hey, a generic pass, hey, a generic fail, just because so much of it was copy and pasted in the data that we had. So it would have just ended up being those two responses anyway. So, but that's all possible, using some type of recommendation system.
Mm-hmm. Yeah, it is worth noting that, the graders' inputs and how they pass fail the students are very critical for how our model learns. So the better the graders do at assessing the submissions, the better the recommendations and the pass fails will be.
Is there a way of identifying the responses that are kind of in that lower, like outside of the confidence intervals? Did you guys think about doing that? Like, first of all, is it possible to identify them? And then second of all, did you think about somehow, where my brain goes is, should those be flagged as the XPs that somebody should manually go and look at?
Yeah, that's a great question, and we have something on that later.
Okay.
All right, so just to conclude here, we conducted 2 post-usability tests with representative users. So one, our star customer success manager, Christine, and a high school Spanish teacher, actually my aunt. So those were recorded for you guys, and Mary will make sure you guys get all of these design files as well. And it was our pleasure improving the grader experience through data for you. We hope you consider some of these features for your backlog and future development work.
Thanks, Liz. Any other questions on the design before we move on?
When you were thinking about the user experience, what made you decide that you should make visible that something was auto-graded versus not?
Yeah, that's a great question. Partially, it's because if I gave the feedback, I would want to know if I addressed the submission or the model did, or maybe you guys are passing the grading back and forth, like you're not all grading the same person. I'm not super clear how that works today, but maybe Taylor graded number 2 and I'm on number 3, so I want to go back and see, why did Taylor pass her when there was, only a 1-sentence response or something like that. So.
I'm sorry. So actually the interface that I'm looking at with Mandy's a reviewer, or Mandy is the user?
Mandy's one of the students.
One of the students. So that's what I was wondering from a student's perspective. I'm just curious, like, what was the thought process around making it visible that it was auto approved?
So this view is for the graders, though.
Oh, okay.
So this is not, this is just from the main page that you can click in, and as a grader or frontline champion, then I can see like what exactly has Mandy been doing.
Okay. For playlist.
Yeah, so definite future considerations. What pieces of this should the students have access to?
Okay, sorry about my confusion. I just saw Mandy's name and profile, so I assumed that it was her page, and I was. Okay.
Yeah, and that's also my fault. I'm trying to incorporate elements of the profile into this. So again, to try to save you guys some work where there are pages already developed.
Mm-hmm. No,
so if it doesn't make sense for a student to see it,
Yeah. Great.
That's wonderful.
Thank you.
Thanks, Liz. And, right. going to go into our executive dashboard, and Tara is going to take us through this.
Great, thanks, Mary. So our executive dashboard is allowing us to interact with our data, and it is a two-part system. So the first dashboard is going to look at who the students are in our program, and the second one is going to evaluate some opportunities where LRNG could expand. And although we chose not to incorporate that demographic information to inform our models, it's really important to understand our student base and who is participating in this program. We're now going to switch over to a live demo, and this is on Tableau Public. We'll take a look at our first dashboard, which looks at our One Summer Youth Employment Program. And on this top left-hand corner, you're going to see a geological view of our student base. So for every blue dot, that means there's at least one student participating in that particular zip code. And in the background are layers from the 2018 census information. And in here we have the median age, the household income, gender, racial information. And in the top right-hand corner is the proportion of students by zip code. So that allows you to see where we have the highest density of students. So if Mary was to click on 60620, for example, that's our highest concentration. And it's going to highlight that one data point on the map, theoretically.
Bells.
Yeah, so if we change that data overlay to the drop down and look at our median household income, you're going to see that it's like a really light yellow. So that's indicating from our legend that there is $42,000 per capita per year for that specific zip code. So this kind of goes to demonstrate that we are reaching a low-income youth that's in line with LRNG's mission. And then in the bottom right-hand corner of that plot, you're going to see the information by gender. So that is also interactive by the zip codes, or you can look at it as a entire population. And you can see here that generally we have more females participating in this particular program, and they have a slightly lower failure rate than the males.
Yep, awesome.
Yeah, so now we'll flip over to the second view, which is our potential for expansion. And in that top left-hand corner, you're going to see an opportunity by zip code matrix. And those areas in pink are the areas that we have classified as being areas for high opportunity. And this is a two-part system because LRNG aims to find partnerships with cities. We're looking at those highly populated areas, and we're also looking to help those low-income areas. So you'll see a poverty line drawn there for a family of four, which is very low at $25,000 per year. And then on the right-hand map on the top there, those pink areas are those same high opportunity areas. So for example, Bronx, New York, or San Antonio are some of the areas that we could look towards expanding. Those blue areas are where LNG already has a presence and where we've partnered with some organizations. On the bottom left-hand plot, this is a really awesome visualization from bear.org. And this looks at the incarceration rates over time. And you're able to look back at 1970 forward. And it also shows the density and the incarceration rates in a twofold system. So it provides a lot of information. On the right-hand side, we're looking at the median high school graduation rate. And this is rolled up from all the school districts at a statewide level, where the lighter the blue, there's a bigger opportunity to have intervention with those students. So combining all these together, you can kind of begin to focus what areas you want to expand in. For example, you might pick Miami, Florida, because it is on our opportunity index. You guys already have a presence there in Florida. There is high incarceration and a low high school graduation rate. So that is the two dashboards here, and let me know if you guys have any questions.
Say more. Could you say a couple more sentences about the opportunity index?
Sure. Yeah, that was just pulling from the census data 2 pieces of information by zip code. So that is looking at the population and just kind of focusing in on those more densely populated zip codes. And then you can kind of toggle those bars depending on what your needs are, but it's also highlighting those areas that are under $25,000 per household.
Got it. Okay.
Great.
Can we do that by neighborhood in cities?
Yeah, there's so much opportunity here to really get into some census data. We came across some really good visualizations in our research, but a lot of the websites don't necessarily let you download that data. So some of it's a manual process, but there's so much you can get at a citywide level, zip code, or county and state. So it's just a matter of trying to acquire that information, and then it's really helpful in trying to hone in on the areas that will benefit the students the most.
Excuse me.
Yeah, now Mary's going to do our recommendations and conclusions.
One quick question though, is there a way for us, I guess the census data only comes out once every 10 years, sort of as we think about how we want to show our impact on changing folks' opportunities, is there a way to use the data to enable us to show impact over time?
I think
Yeah, and there is,
Mm-hmm.
yeah, depending on the source you're using, you can drill down to information a little bit more recent. One of the areas that we saw a big opportunity was looking at the school district information, especially in Chicago. There's some really good resources I came across where you can look at those zones. And if you could kind of go in on those boundaries and see where you guys actually have programs, I think you might be able to see some scalable changes there.
Okay.
All right, so we have our solution suite. So we have a few recommendations to keep all of this moving forward. As we were just alluding to in the data, there are a lot of opportunities to expand our current data gatherings. So Nick pointed out some with timestamps to have a better understanding of user experience. There are opportunities to use what we have in Google Analytics to combine into that. The more that we can move into census data and other open data sources, the better. In modeling, we've kind of talked about this a little bit. This graph takes us, helps us understand that we can set, in implementation, we can set thresholds. So the one recommendation here is to say, take this middle set that is the most likely to be possibly miscoded. So the mathematics of it is its probability, so it's 0 to 1, and is it closer to a 1 and a pass, or is it closer to a 0 and a fail? So we take the people in the middle and leave those for manual grading. And we can set that threshold wherever we find appropriate and adjust that relatively easily within the system. To, especially as we're first implementing this, to make sure that we're keeping the quality of where we want it. Also, in a similar way, the auto grade parameters, do you turn it on for everyone? Do you turn it on for a certain group? Do you turn it on for just a certain XP? Do you turn it on for a certain playlist? All of those things are parameters that we can play with during implementation. So the feedback system, we had a question about that, so we were kind of talking for that. So to continue youth engagement, we think immediate feedback is really valuable for that. So that's just another reason and a value add for implementing the modeling. But also getting into that user-specific feedback. That's something that we looked at and were initially interested in modeling, but we found that the data that we had so many copy and paste responses that we didn't have good data to model off of. So there are other ways that we could approach that problem and address it, but it's definitely a recommendation for future, making sure that they're getting, so that students are getting immediate feedback and personalized feedback through the model. And then a little bit more about future modeling, giving graders the opportunity to like and dislike past failure recommendations is just one more metric to improve the model, along with the override. And we have the opportunity to define hard business rules. So we could say something like, if you typed less than 5 words, it's just an autofail.
Yep.
And tell me more.
Yep.
We can say, we were talking about some of JVR's rules in Deep Dive. We can look at all of those and apply them into the model as well. So all those things we should look at, and a few future opportunities more to add on. Past just implementation, Nick's Shiny web app, we can add JavaScript on top to make sure that it reflects all of the LRNG branding. We can get into additional demographics with the data, with crime rates, school ratings, all of that. There's just more and more data that we can pull in and understand more about what impact we're having in what areas. The design, focus groups on user experience with the skeleton design, keep building that out and iterating and improving on the design. And the modeling for future opportunities would be to evaluate some neural networks so that can address both text analysis, but image recognition is something neural networks are really good at.
The user interface, so the Shiny, I'm just making sure I understand. On the web app, we could use that and not have to redo a whole set of things on our back end.
Potentially, yeah.
And then is there a way to use whatever on the user interface around the grading, the grade assist?
Yeah, the design that we made. I am not certain. Megan probably can speak more to what implementation on that would look like. We have.
It can be a starting point and definitely something we can utilize to get feedback and then go from there.
That doesn't tell me anything.
Yes.
So what you just said is we can use it for user research, but that doesn't affect our user's experience. So
we could implement that look and feel if it makes sense.
I'm asking a different question, which is the Shiny app is a separate way to do it. It is an app that exists on its own that can get connected to a platform. On the UI for the user, there's no separate app that can just get connected. You're telling me it has to be built.
Right.
Those were designs.
Yeah. Awesome.
Great. That's
Okay.
So we have all of our materials and our whole paper write-up for you. We've got everything zipped up. So in case you're interested in reading the 40-page report, we've got it.
Yep.
But everything is deliverable. We can take all of the prototypes and build on them today. So it's all available. Does anybody have any questions or?
It's an outstanding amount of work. How long have you guys been working on this?
So we formed groups week 2, and it is week 9.
Okay.
Yeah.
That's outstanding.
Yeah, and it was really insightful.
Hugely, hugely helpful.
Yeah.
Really, really great work, you guys. Thank you.
Yes, and I have to go, so good job.
Thank you so much. And we will absolutely build on this, so thank you.
It's a great cause.
Congratulations on completing your capstone.
Thank you.
And thank you for.
Thank you.
Yeah, we're really honored to have had you guys work on this project, so thank you so much. You got a question, Mr. Demetrius?
No, I didn't have a question. I just really like the data thing. Like, I was really like sitting here like, wow, this is amazing that y'all pulled all this data in from so many different categories, like the demographic or the incarceration rate or, like who uses it the most, or even if people use it and by the zip codes. It was just really mind blowing.
Thank you, guys.
Thank you.
Yeah. Thank you.
Thank you. Really enjoyed learning about LRNG. You guys have a great organization, and we're excited to help you guys out.
This is a huge advance for us, so thank you. And I
Our
hope
pleasure.
that while you're moving on, I hope that we can draw back on your expertise and continue to be connected with you.
For sure.
Of course.
They're stuck with me forever now.
Great,
So-
great. Okay,
Good, good.
thanks so much.
Sure. Thank you.
Cool.
Thank
Thank
you.
you.
Okay.
Thanks. Bye.
See ya.